Hey y'all. So we're going to talk about the Lutheran system today. So let's go ahead and get started. So here we have the objectives listed. So if you want to go through and find exactly what you need, everything is in order. A couple of them might be combined in the same slides, or talked about in our PowerPoint presentation. So we'll keep on going. Here's the rest of the objectives. And we'll start with the background of the blood group system. So a little background about the discovery of the blood group systems. So it started in the 1900s by Carl Landsteiner, who's pictured here. So he discovered why some of the blood transfusions were successful while others were not. He discovered the ABO blood group system in 1940 and continued to discover the M and N, P, and RH systems. So Landsteiner found that there are substances in the blood, so like antigens, antibodies, that induce clumping of the red cells when red cells of one type are added to those of a second type. Then he recognized that three groups, so you have A, B, and O, based on their reactions to each other. And then a fourth group was later found by a different research team, which would be the AB group. So the discovery of the RH system was also by Carl Landsteiner and Alex Weiner in 1940. And they made this discovery because they tested human red cells with Anacera developed in rabbits and guinea pigs by immunization of the animals with the red cells of the rhesus monkey macaque, mulata. So with the discovery of the ABO and RH systems, it was easier to discover other antigens or antibodies that were causing reactions that were independent of the ABO and RH systems. So the first blood group system that really wasn't discovered by Carl Landsteiner was the Lutheran system. And so that was discovered in 1945. So 5 years later, after they had discovered all of those other blood group systems, ABO, RH, M, and P. So who discovered the Lutheran system? So that was Collender, Raisin, Peyko. And so the first example of an anti-LUA, so it was discovered in the serum of a patient that followed a transfusion of a unit of blood carrying the corresponding low-frequency antigen. So the new antibody was named Lutheran, which was a misinterpretation, actually, of the patient's name Lutheran. And they showed that the Lutheran system was independent of all of the ABO, RH, M, N, and P group systems in 1940. Go. So a little bit of background just on the Lutheran system. So all the Lutheran antigens, they're all different variations of a basal cell adhesion molecule, also known as BCAM. So they're also, there are 19 known antigens in the Lutheran system. So some places will say 18, some will say 20. 19 for sure are known. And then there are 4 pairs of anti-theolytical antigens and 11 high-frequency antigens. And then the antigens are located on 4 out of the 5 immunoglobulin domains of both the isoforms of the Lutheran glycoprotein. So all the Lutheran genes, they are all located on chromosome 19. So on this little chromosome chart, chromosome 19 will be on the very bottom left. So the whole system is based on the expressions of 2 codominant alleles. So that will be LUA and LUB. And there was antigens known as AUA and AUB that were thought to be an independent system, but they were eventually found to be antigens that came off of the basal cell adhesion molecule gene as well. So they were later grouped into the Lutheran system because they're on the same gene, on the same cell, so they're part of the same system. So most of the Lutheran most of the Lutheran antigens, are high prevalence. So that would be LUA, AUA, and AUB. So those are polymorphic. And the only ones that are low prevalence, that would be LU9 and LU14. So the Lutheran antigens and antibodies, so they tend to have mixed field reactions. So when you're identifying any of the abnormal antibody screenings or anything like that, if there is a mixed field reaction, the Lutheran system needs to be one of those that are ruled out, because that is the only way they're really expressed. So let's go along to the fetal cell expression. So LUA is expressed on the fetal cells and also on the placenta cells, and so that will prevent any antibody transfer to the fetus. So there's no visible impact on the pregnancy. So with respects to the hemolytic disease of the fetus and newborn, LUA is often present on the placental tissues. So that means adsorption of maternal IgG antibodies onto the placenta cells prevents antibody transfer to the fetus. So there's no apparent impact on the pregnancy. LUA is not a cause of hemolytic disease of the fetus and newborn, which is awesome. That doesn't cause any of those diseases or pathologies. So then we're going to go on to enzyme reactions. So the Lutheran system is unaffected by most of the common enzymes. So that's including physin, papain, or bromelain. So they don't have any effect. So to have an effect, you need to use either DTT, trypsin, or chromotripsin. So those will either reduce or destroy the antigen if you wanted to get rid of them. The Lutheran system is typically just IgM, and that is mainly LUA is IgM. There are some associations with IgG and IgA, but those are components in LUB. So the antigen reacts at both warm and cold phases, depending on which phenotype. And then there'll be a table later in the slides that will show you exactly which one is which. And then the LUB, so it will react with all cells but screening cells. Or my bad, backtrack. They'll react with all cells except for the autocontrol. Because 99% of the cells express LUB antigen, and the reactions are typically weaker with the dosage effect. And then we're going to have a little break here. Let me move my awesome face out of the way so you guys can see. Go ahead and read these enzyme little memes. I thought they're pretty funny, so go right ahead. And we'll continue on. All right, if you need any extra time, go ahead and pause the video. I love the Amoeba Sisters, and I think they're really funny. Just wish they had some more in like blood banking. So the next slides, we're going to do antigen biological function. So the primary function of the Lutheran system, or the Lutheran glycoproteins, is on the red blood cells. So it can involve the maturing red blood cells and taking them from the bone marrow and putting them into the peripheral circulation. But they can also be involved in the vascular occlusion and thrombotic events, such as complications of sickle cell disease and polycythemia vera. All right, so some of the Lutheran pathologies. There isn't very many. So, again, if there is a Lutheran pathology, there has to be a mixed field reaction or not. It is kind of rare. So any mixed field whatsoever needs to make sure that you have Lutheran completely ruled out. So the Lutheran system generally only has relatively benign reactions. There are occasionally where you can have delayed hemolytic transfusion reactions and hemolytic disease of the fetus and newborn. So the phenotype that will be causing the diseases is LUB. So we'll go over some of the symptoms of a transfusion reaction, which are caused by LUB phenotypes. So that will be back pain, blood in the urine, fever, chills, fainting, flushing of the skin, and flank pain. And then to kind of treat these, you're going to keep the IV in, and you're just going to keep the line wide open with normal saline. Make sure you stop the transfusion immediately, and then intervene as any signs and symptoms appear and monitor vitals. There isn't a whole lot you can do to treat those hemolytic transfusion reactions besides take away the blood that's causing that reaction. Make sure you get the patient screened and the donor as well to make sure we don't continue with any of those reactions if giving any more blood products. So the next pathology that we're going to go over is actually hemolytic disease of the fetus and newborn. So however, LUA did not cause this, but LUB can. So some of the symptoms in like a newborn, so that'll be pale skin, yellowing of the amniotic fluid, umbilical cord, skin and eyes, and then enlargement of the liver and spleen and swelling of the body. So all symptoms dealing with extra bilirubin and all that. Fun stuff. So to kind of help treat those newborns, what we're going to do is feed them a little bit more often with a lot of fluids. Want to get all of that excess bilirubin flushed out, make sure their system is functioning. And then they can also be in light therapy beds for infants, those little sauna beds. So if the pregnancy is still going on and the baby has not been delivered yet, so that will result in mild anemias in the mother, hyperbilirubin anemia with jaundice, and more severe anemias with enlargement of the liver and spleen. And then in some cases, there's hydrops fatalis, which is also a possibility, but that's extremely rare with the Luthern system to cause that. So anti-LUA has no immediate hemolytic transfusion reactions or related reactions or delayed reactions, my bad. And it's also extremely, extremely rare to see the hemolytic disease of the fetus and newborn. However, anti-LUB, that is the one that causes all the problems. So it is the reason that they could be delayed hemolytic transfusion reactions or hemolytic disease of the fetus and newborn, because that is such a low incidence antigen. All right, on to frequencies. So throughout the population, there's a couple different frequencies, and one of the most common frequencies is the LUA A minus B positive, where the most rare is the A negative B negative. So we have this chart here that you can look at. It's kind of quick and easy. You can see the genotype of each one, each possibility, and then the frequency of each. So you can see the most common is the A minus or the A negative B positive, and then that really, really rare one at the very bottom. I put those two close together just so you can see right off the bat they are the most rare and the most common. So the probability of a patient forming anti-LUA would be really low because essentially 92% of the donor population is LUA negative. So that's only leaving 8% to be LUA positive. So LUB is high incidence. It's a high incidence antigen. So the probability of a patient forming anti-LUB is also low because only 0.15 or 15% lack this antigen. I guess 0.15, not 15%. So then the Luthern system is antigenic expression, so it's highly variable among individuals. So the antigen development starts in early age and has poor expression of these antigens until about 15 years old, and then it'll just continue to become stronger and stronger. So here is a population breakdown of the Luthern phenotypes. So you can go across, there is a couple different geographical populations as well to see if there's really a big difference in there. And for the most part, you're going to have really common A negative, B positive Luthern types. So you can keep this for your reference. And let's go on to dosage. So the dosage effect is different in an antibody reaction strength depending on the quality of the target antigen present on a target red blood cell. So like most blood group systems, the alleles are inherited in a co-dominant manner. So if an individual inherits alleles for both LUA and LUB antigens, that both will be expressed on the red blood cells. So because both of the antigens are expressed on the same cell, they're considered to have a single dosage. When an individual inherits a homozygous allele, then an individual, it's also known to have a double dosage. In this chart, I made it really easy to show you what single dosage and what is the double dosage. So you can look real quick through this and be like, there's the dosage. So any of the antibodies against the LUA, they may react significantly stronger when mixed with an LUA A positive, B negative, than with the double dose, which is an A positive, B positive, which has less of the LUA, which is a stronger antigen to test for because it's present on essentially 99% of the cells. Here's another brain break and talk break. So go ahead and read these. These were Jess's favorite ones. Alrighty, so some clinical significance. So anti-LUA and anti-LUB, so they tend to be IgM or IgG. So in context of the transfusion, anti-LUA is rarely clinical, significant for most patients. Anti-LUB in regards as clinically significant, just because it reacts at 37 degrees C and with AHG. So the blood should not be withheld in emergency situations. A severe or acute hemolysis has not been reported with LUB, so it is safe to go. There might just be a mild reaction. Like stated in the pathologies, normally the reactions are benign or not very severe. So LU3, which is anti-LU3, is a super rare antibody produced by immunized individuals with the recessive type of LU of the Luthern system A minus, B minus, or the LU null phenotype. So if you do have one of these patients, the blood that should be given in an emergency or in a transfusion should be LUA negative, B negative. So that should be used. Anti-LUA, so they're often IgM saline agglutinates, so they react at about 18 degrees C or below, but they also may be partly IgG and react by the antiglobin technique. So mild cases of hemolytic disease of the newborn have been reported, but anti-LUA has not been clearly incriminated as the cause of any of these red cell destructions. When anti-LUA is detected in patients' pre-transfusion samples, there's usually no requirement for testing of, or no requirement for selection, of LUA negative donors for red blood cells, because 92% of the units are going to be LUA negative. So here's a little chart exactly of which antigen reacts with what. The only thing we needed to add on to here was the anti-LUB could also react with AHG as well. Let's see, then we'll bebop down one more. So the in vitro characteristics, there isn't really a lot to this. So they just haven't been reported in the Luthern system. So they normally exhibit like a loose mixed field reactivity, but that's about it. So they say even some of the most seasoned people could miss it in the blood bank, just because it is such a slight and small reaction. So here is some of the inheritance. At the bottom of the screen, we have diagrams of both the LUA and LUB antigens. You see there's a slight difference, but not much. The main difference is if you look closely, there's a yellow and blue section. The LUB has more of a branch section on that part. So the dominant and recessive types are both LUA A negative, B negative. So they're a recessive X-linked inhibitor type. So in all available family studies that we found is the LUA A negative, B negative phenotype showed a dominant in the LU mode of inheritance. So it's homozygous inheritance of a silent allele is another mode of inheritance for a null phenotype. So individuals with this second type of LU null phenotypes are usually found in like one generation. In the Luthern system, there's a type of LUA negative B negative that arises from homozygous, my goodness, inheritance of an amorphic recessive gene. LU at the LU locus. So that's far less common, really rare than the IN-LU type. And that is kind of what wraps up the Luthern system. Here's a few citations. Feel free to go, and if you want a little bit more information, there are some really good pages in here. If you just want more in-depth or longer explanation of certain things. But that is all for the Luthern system, and I hope you liked it.